In the next question, it says several electric bulbs designed to be used on a 220-volt electric supply are rated 10 watts. So each bulb is rated 10 watt. How many lamps can be connected in parallel across the two wires of 220 line if the maximum allowable current is how much it is? 5 ampere. So we have like this, like these bulbs are connected in parallel, right? These are identical bulbs which are identical rating are connected in parallel. So what we know that the in case of if I talk about the current in each, like say each are using I1 amount of current, right? And there are n of them, so we can say that the total current in the circuit will be n times I1. And why so? Because they are connected in parallel, and you know that the total current in parallel is the sum of individual current of the appliances. So this is the idea for doing this question. So we need to keep in mind that the total current, which is given I here, look into this, what we know that the total current is given how much? 5 ampere. So this is 5 ampere, and we have to find n in this case. This is what we have to calculate the number. Now, what I'm going to do first, I'm going to calculate I1 here. So we know that P is equal to VI. So we are looking for the power, which is 10 watt, is equal to V, which is 220, into I. Will take this as I1. So I1 comes out to be what? 10 divided by 220. On reducing, we get I1 as how much? 1 over 22 ampere. So this is what the current for each bulb, right? The current used by each bulb. And now check, we have to get what? This I1. So as I said in the beginning that we know I here as 5 ampere. So I'll replace I with 5 ampere. N is the number of bulbs which we have to calculate, and each bulb is of how much? 1 over 22 ampere. So by cross multiplication, we can say 5 multiplied by 22 should be the number of appliances or number of bulbs, which comes out to be 110. Yeah. So I'll say that 110 is the number of bulbs used. Now let's move to the next question. In this question also, it says similar to the previous, two lamps, one rated 100 watt 220 volt and the other which is 60 watt 220 volt are connected in parallel to the electric main supply. And the question is what current is drawn from the line if the supply voltage is same, that is 220 volt. From that means it is the same source. So we know that the devices here are connected in parallel, and as we know that in a series the total current will be equal to I1 plus I2 here. Now what we are going to do here is to apply this relation P is equal to VI and obtain I1 and I2 and then place here to get the total current. Now power in the first case, as I can see, it is 100 watt is equal to, and the voltage is 220, so that is 220. And as I said, I'm taking I1 here. So I1 comes out to be what? 100 divided by 220 ampere. So we got the current in the first case, that is I1 here. And likewise, I'm going to get the current in the next case. So if I calculate the, say, using the same relation, P is equal to VI, power this time is how much? 60 watt. So 60, and this is how much? 220 voltage, and I'll take current as I2 in this case. So this is 60 that divided by 220 is equal to I2. Now as I said in the beginning that the total current I will be obtained as I1 plus I2. So I1 is how much? This is 100 over 220 plus the I2 which is 60 over 220. LCM remains the same, so it's going to be 160 over 220 can be reduced further. As I can see, it comes out to be 8 over 11 ampere. Well, in the exam, you should write down in the reduced form, that is in decimal. In the next question, it says, compare the power used in 2 ohm resistors. So this is important to remember, only for 2 ohm resistors in each of the following cases. The case 1 is a 6-volt battery in series with 1 ohm and 2 ohm resistors. So there are two resistors, that is say 1 and the other is this, and they are connected in series with a battery. right? So this is of 1 ohm and this is 2 ohm. But we have to remember that we have to calculate the power at this. And similarly, there is another case, that is in case 2. As you can read in the question, here the devices are connected. Let's say if I read the other one, 4-volt battery in parallel with 12 ohm and 2 ohm resistor. Well, in the first case, the voltage supply is 6 volt, and in the second case, the two resistors this time, one is of 12 ohm, yes, and the other is of 2 ohm, and they are connected in parallel with the circuit. And this time, the voltage supply is how much? 4 volt. Now, here too, you have to remember that we need to calculate the current only across 2 ohm resistor. Now check here, there is something that you should remember, that we have two relation for power. P is equal to V square by R and the other as P is equal to I square R. We use this relation when the voltage is same and we use this when the current is same. So what you know that V remains same in case of parallel. So we'll be applying this formula over here. As you can see, it's a parallel connection. And conversely, where is I same? I remains same in series. So we'll be applying this relation. So let's solve this. In the first case, we are going to apply this relation. As I said, because in current, what remains same? In current, sorry, in series, current remains same. So therefore, in order to get power, I need current. So in order to find current, we'll be using Ohm's law, provided we have the total current known. So first I'll get the total resistance in this case. Total resistance R is equal to R1 plus R2. That is 1 plus 2. So the resistance here is 3 ohm. Now we can apply this relation which I said, P is equal to V square by R. So P is equal, sorry, I square R. But then we haven't calculated I. So using Ohm's law, V is equal to IR. So I'll get I is equal to V over R. V, which is 6 divided by R. Well, check here. Here the total current in this circuit, right? I'm looking for total current in this circuit. That comes out to be 2 ampere. So once we have got the current here, now I can apply this relation, P is equal to I square R. Now something important to know, that I is 2, so it's 2 into 2, but the resistance is only for here, right, at this point. So that's why I'm multiplying with 2 ohm. So that comes out to be 8 ohm. Now for the other case, as we know that V is equal to V square, and is applied here. Why? Because these devices are connected in parallel. So if I say that we need V, which is already given to us, so it'll be V square, which is 4 into 4 as for this, divided by R, and R is across this only, right? Across this 2 ohm resistor. You can see the question, you have to get around 2 ohm resistor here. So this is can be reduced by 2 times, so power comes out to be, this is not 8 ohm, this is 8 watt. So we'll find that power in both cases are same. So this is how we will do this question. In the next question, it says a torch bulb is rated 2.5 volt and is 750 milliampere. And what we have to calculate is power, the resistance, and the energy consumed by the bulb in 4 hours. These are the three parts of this question. So first I'll write down the information we have in the first part. We have to get power, right? Okay, but then first write on the information. Voltage supplies 2.5 volt and the current here is how much? 750 milliampere, right? So 750 divided by 1000. That should mean ampere. You can reduce it. So I comes out to be 0.75. Or we may write in fraction, that comes out to be 25 3 times and 4 times. So it's 3 over 4 ampere is the current. Well, in the first part is what we have to get power, and P is equal to VI is what we are going to apply. So V is how much? 2.5. 2.5, that is 25 by 10 into 3 over 4 can be reduced 5 times, 5 2 times. So power comes out to be 15 over 8 watt. So you may reduce it in decimal in the exam. Now this is what we did the first part here. Now in the next part they are asking the resistance here. So that's very easily can be done using Ohm's law. What we know that V is equal to IR, right? So R is what we have to get. So let's place the value. V is how much? V is 2.5. How much is I? This is I is 3 by 4, and the resistance is what we have to get. So we can do multiplication. It's 2.5 into 4, that divided by 3. So the resistance comes out to be how much? This is 10 over 3. So which we may write 3.33 ohm. So we got the answer for the second part. Now next is what we have to calculate the energy consumed in 4 hours. So energy is what? Power into time, right? So we are going to apply this relation that energy is power into time to do it further. So energy is equal to power into time. Power is how much? Power is 15 over 8, and time is how much? 4 hours. So let's keep it in hour first, or we may write 4 into 3600 seconds in order to get in SI unit. I'll reduce this by 2 times, 2 1 times, 2 1800 times. So whatever it comes by multiplying these two numbers. But then since we have to write down in the reduced form, in the scientific notation, you should multiply first 15 into 18. So 15 multiplied by 18 is how much? It is 270. 270 followed by 2 more zeros. So in scientific notation, or you may write this in joule only, that is all fine, or you may write 2.7 into 10 raised to the power 4 joule. That should be the answer for this question.